Okay, so good morning students. So yesterday we have discussed about the introduction for beams chapter. So in that beams chapter there are three types. One is laterally supported, one is laterally unsupported and built up beams. So laterally supported means supports will be restrained at compression flanges. Laterally unsupported means the opposite one for laterally supported, supports will not be restrained at compression flanges. So okay, so to do laterally supported or laterally supported beams. So first one, laterally supported beams, the design steps. So first we should know the calculation part for laterally supported beams, how the design steps will come as step by step. So first one, calculation of loads. So in given question it will give dead load, live load or imposed load or something. So we should take the calculation of loads by calculating factor load. So given loads, to calculate factor load means 1.5 into dead load and 1.5 into live load, and combination of both dead load and live load we will call total load. That is the first step. Okay, second one, calculate maximum bending moment and shear force. So maximum bending moment means if simply supported beam WL square by 8, if cantilever beam means WL by 4, and shear force WL by 2, and if cantilever beam means WL. So bending moment means perpendicular to force into perpendicular distance. Shear force means force which is acted on member. Okay, that is calculation of maximum bending moment and shear force. So third step, selection of section. So how we will select the section? Already I told what is the selection of section means. We will calculate here for heavy beams or lengthy beams or weight beams which are called ISWB, ISHB, ISLB. Okay, so we will select the section by calculating the section modulus. For plastic section modulus, ZP. So ZP is equal to M into gamma M naught by F5. So M is maximum bending moment, gamma M naught is table 5, from table 5 value 1.1 or 1.25, and F5 is characteristic strength for steel 250, which is candidate. So we will get the ZP plastic section modulus, and we will take by the calculation of plastic section modulus, we will select the section if ISMB or ISLB or ISHB, and we will continue the problem. So by knowing the plastic section modulus ZPZ value, we will know the we will calculate the properties of section. We will write the properties of section by taking the help of ZPZ value. So if the ZPZ value is 1811, so by example 1811, we will see the nearer value or more than 1811, and we will take the section for example. Okay, so by doing the problem we can understand. So okay, so after that fourth step, write the properties and section. So here we will select the section ISLB of 500, ISLB 800. So write the properties of section. The properties are H, width of flank, thickness of flank, radius of gyration, height, moment of inertia, ZPZ, plastic section modulus, elastic section modulus, ZGZ. All properties we will write. Okay. Next, section classification. What is the section classification means? Mainly here the section which we have assumed, which is plastic or non-plastic, So here section classification, plastic or non-plastic, while we will do the problem, we can easily solve. So there are two formulas for section classification. While solving the problem, I will see. Next one, fifth step, calculation of design shear stress. So design shear stress VD is equal to H into TW into F5 by root 3. So here maximum, yesterday I said, as the design criteria which is depends upon morely shear force. So all design criteria should be greater than V. All design criteria should be greater than shear force. If not, proceed from step 3. So reselect the section, again calculate the problem from step 4 onwards. So here VD must be greater than V. VD must be, design shear stress must be greater than maximum shear force. Otherwise redo the problem from step 3. Next, calculate MD, design bending strength. Design bending strength, the formula for design bending strength will be in page number 53 code book 8.2.1.3. So 8.2.1.3, the calculation of design bending strength. So if MD greater than M, so MD also should be greater than moment, bending moment. Otherwise, reselect the problem, reselect the section and do the problem. Next, step 7. Here onwards, the checks will come. So check for deflection. So check for deflection. So here the maximum deflection we know. If simply supported beam with UDL, maximum deflection is 5WL for 380 for A, or point load means WL for 48A. So we should know the maximum deflection formulas, and the maximum deflection will be table 6 and permissible deflection will be formulas. So this is the delta permissible value and maximum deflection will be from table number 6 in code book. So you should be delta max must be greater than delta permissible value. Otherwise, reselect the section and do the problem. Next, check for web buckling. So already we know. So buckling means, so if beam bends, it will call bending. If column bends, it will call buckling. So buckling formula, FWB is equal to B1 TW FCD. So FCD, to calculate FCD value, no, table number 9C from code book, and calculated FWB, web buckling also should be greater than shear force. Otherwise, from step 4, you should redo the problem by reselecting the section. Next, check for web crippling. Crippling means twisting the load. So if the load acted and the member is twisted. Okay, so further down the formula, FCW is equal to B1 TWF by gamma m naught. B1 bearing strength, TW thickness of the Fi 250 and gamma m naught. So by calculating all, we can get the value of FCW, which is greater than V, which must be greater than V. So all the checks, all the design moments criteria should be greater than shear force. If not, reselect the section and do the problem from step 4. Okay, so keep in mind the check for deflection, check for web buckling, check for web crippling, and check for shear. Check for web deflection, check for web buckling, and check for web crippling. All same for built-up beams, laterally supported and laterally unsupported. Checks are same for 3 methods. So keep in mind, check for shear, check for deflection, check for web buckling, and check for web crippling. The checks are same for laterally supported, laterally unsupported, and built-up beams. So this is the design procedure for laterally supported beams, which is very important for 14 marks. Okay.